topic we have the Lewis concept of acid and bases. So the main topic is Lewis concept of acid and bases. Let's have an introduction that what does the Lewis concept is going to be explained. So why there was a need for the explanation of the acid and bases by the Lewis. In the previous we have the Arrhenius, two scientists. The first was Arrhenius and the second was Bronsted-Lowry concept. Bronsted-Lowry concept. These two scientists can explain most of the acids and bases, but it was believe both of them must believe that the acids must have the proton, that it may donate or it may you can say that lose or hydrogen can produce the hydrogen ions. Now after their explanation, the third classification about the acids and bases was done by G.N. Lewis. G.N. Lewis, and the year 1923. And basically, his definitions was the total emphasis on the role of role of electron pairs in an acid-base reaction. So his concept were more precise and more you can say that explained in a way that it just take all the acids or it just classified all the substances as acid as base because all the atoms have electrons in them, and when these electrons are going to be lose or the gain, then we can easily categorize the substances as acids and bases. So according to him, let's see that what are the Lewis acids. So Lewis acid basically it is a species, and that species may be ion or maybe a molecule. It can accept the pair of electron, accept the pair of electron. So the substances that can accept the pair of electron are known as Lewis acids. Known as Lewis acids. So we have to just look on the pair of electrons. If any substance is going to accept the pair of electron, then it is known as the Lewis acid. So let's have an example of the Lewis acid, that what type of substances we can call as the Lewis acids. So the example we have BF3 boron trifluoride plus we have ammonia NH3 here, and nitrogen is having a lone pair. Now, what does mean by lone pair? A pair of electron that is not going to participate in the chemical reaction or non-bonded electron. After the reaction, we have a look that there is a donation of proton, and the product we just gain like BF. If I'm going to draw the structure of boron trifluoride and the bond with the electron pair or the lone pair of ammonia. Now this is the main product that we gain. If we have a look here, BF3 as it has except the electron pair, so it is known as the Lewis acid. It is known as Lewis acid because it has except the electron pair. So this is a simple example that is going to explain the Lewis acid base concept. On the other hand, if we have another example related to the ions, if I am having H positive ion along with the reaction of H2O, here hydrogen and oxygen. Oxygen is having two electron pair. After the reaction, we just gain the product like hydrogen, and hydrogen, and it is having the positive charge. So here we have looked at the hydrogen, it is electron deficient, so it can accept the electron. So H positive ion will act as Lewis acid. So the simple way to categorize the Lewis acid, we must have a look at any substance that is electron deficient. Electron deficient means the cations, they may work like an Lewis acid because as they are electron deficient, they are cations having the positive charge, they can accept the proton, so can be act like an Lewis acid. So you guys must remember that how we can be able to recognize the acid. They must be cations, they must be electron deficient. Next we have the concept of Lewis bases. So it is the inverse of the Lewis acid. So the Lewis bases, they can donate the electron pair. They can donate the electron pair. So the substances that are going to donate the electron pair are known as the Lewis bases, or we can say that Lewis base. Basically, the substances are having negative charge, and negative charge species are known as anions, and the substances whose octet is complete, these substances are going to be act like a Lewis base. Why these substances are going to be act like a Lewis base? As anions having negative charge, they have an extra electron, so they can donate the electron easily. On the other hand, if the substance is having their octet complete and they are having a lone pair over there, and lone pair is the pair of electron that is not going to participate in the chemical reaction, they can donate the electron pair and can be able to act like a base. So let's have a example for the Lewis base. We have the reaction of H positive ions and with ammonia NH3. Here nitrogen is having a lone pair. After the reaction we just gain the reactant by writing the open structure for the ammonia NH3 and this hydrogen. So we just gain a positively charged ammonium ion. It is known as ammonium ion. Here we have see that H positive, it is electron deficient, it is a cation, it can accept the proton, and in this reaction it has already accepted the proton pair, so electron pair, so it is known as the Lewis acid. And here NH3 ammonia, it is having the lone pair, its octet is already completed, so it has donated the electron pair so it is going to be act like a base, and this is the Lewis acid and base concept. So substances simply that can donate the electron pair are going to be act like base, and the substances that are going to accept the proton or accept the electrons are known as the Lewis acids. Let's have another example for this concept, H positive and plus H2O. After the reaction, we just have a look that the product is H3O positive. Here, H is electron deficient. It accepts the proton, accepts the electron pair. So it is known as Lewis acid. Here, the water, as it donates the electron pair, so it is known as the Lewis base. So this was the concept of Lewis and acid and bases. I hope you guys understand about this concept, and if you have any queries you can ask me about that in the comment section, and I will get back to you guys soon inshallah. For that time, have a good day and Allah Hafiz.